Hi everyone, my name is Pradyumn and today we will discuss the solutions to the problems A to D of Division 2 of CodeChef round which happened yesterday on 31st on December. So let's begin. But before we start, I'll tell you about our courses at TLE Eliminators. So if you are someone who is stuck at solving just one or two problems per contest, then these self-paced courses are what you need. We have divided the course into 4 different levels, so you can start from wherever you are: beginner, pre-intermediate, intermediate, or advanced. You will learn the most relevant CP concepts through recursive lectures by experienced educators, followed by carefully curated practice problems, combined with guided hints and detailed video solutions that help you understand the why and not just the how. We believe in helping you build real intuition. And beyond just learning, you will enjoy leaderboards, gamified progress tracking, internal contests, and PCDs to keep you consistent. And if you need more help, then you will get instant doubt support from our top rated mentors, so you are never left stuck. Pick the level that fits your goals and start learning today. And if you are not sure that which level you should choose, then you can watch this video, which details about how to choose a level. And if you are still not sure, then you can watch the level specific video which details about what are the prerequisites, outcomes, difficulty and topics taught in that level. Okay, so anyways, this is it for the courses part. Let's start with the PCD now. So this was the contest of division 2. The first problem was ones and zeros 1. Given a binary string, fs is defined as follows. A prefix s from 1 to I is called good if it contains at least as many ones as zeros. Fs is the number of good prefixes of the string s. You are given a binary string of length n. Find fs. Okay. So this is a problem which says that just a minute. Yeah. Okay, so this problem says that we have a binary string, that is a string having only zeros and ones, 0 1 0 1 1 0, like this. Okay, and what they are saying is that a prefix from 1 to I, let's say the ith prefix from 1 to I, it is good if the number of ones, count of 1, is greater than equal to count of zeros. Okay, and we have to basically like count the number of prefixes which are good, right? So like in this string, let's say we have 6, n equal to 6, right? So we have 6 different prefixes, that is this prefix, this one, this one, this one, and okay, this one. Yeah, so 6 prefixes like this. Okay, and out of them, if we see, like this one is good because it has 1 1 and 1 0. This one is not good because it has 2 zeros but only a single one. This one is good, this one is good, and this one also good. So we have 4 good prefixes. Okay, so the answer here is 4, right? And the constraint on n is up to 2e5, I think. Yeah, up to 2e5. So if we do n square, then it won't work, right? We have to do O of n. So actually we can simply do O of n by keeping a count. Like we can simply keep a count of the two variables, that is 0 and 1. Like let's say we loop from left to right. Okay, and if we are at ith position, then we can just keep a count that in this prefix, what is the number of zeros, let's say c1, and number of ones, so c2. So we will keep a count of this, and let's say when we are going from I to I plus 1, we can simply increment the count of whatever character that is. So if there's a 0, then we will do c1 plus plus, and if there's a 1, we will do c2 plus plus, right? And while we are iterating from like I equal to 0 to n minus 1, what we will do is we'll simply check if this c2 is greater than equal to c1 or not. right? And if it is, then we will do ans plus plus. Like we will have one more variable which is ans, that is it will count the number of good prefixes. Alright, so we will simply do that variable plus plus. Alright, so this is the solution, like O of n, like we have to just traverse the string only once, so it is O of n. Okay, so I think this should be pretty clear. Like this problem was not very hard, it was very easy for a division to A, but okay. So I'll show the code for this. So I have int t c in t while t minus int n c in n, and I am just taking the characters one by one in the input. Okay, so I have c1, c2 and ans. C1 is the count of zeros, C2 is the count of ones, and ans is the final answer. And for int I equal to 0, I less than a plus plus, char c, c in c. If c is equal to 1, then c2 plus plus, otherwise c1 plus plus. And ans plus equals to c2 greater than equal to c1. So c2 greater than equal to c1, what it means is, like, either it will be true or false, right? So if it is true, then it would be 1, and if it is false, then it would be 0. So accordingly, answer would get either incremented or it won't change, right? And then finally we print the answer. So this is the code, and I think it should be pretty clear. So let's move on to the next one now. So the next one is called 3 paths. For a given binary grid A of size n by n, we define fa as the number of distinct write down paths that can be taken from 1 1 to nn, such that all the cells ij you visit have aij equal to 1. A write down path means that from the cell xy you can go either x plus 1y or xy plus 1. Construct a grid A with exactly 3 paths, or claim that there does not exist any. If multiple answers are possible, all accepted. Okay, so we have that on a grid we have been given a binary grid. I mean, we have not been given, but like, let's say on a binary grid, let's say n by n ki grid hai, so let's say n is equal to 4. So let's say we have this grid 1 and okay, so we have this grid of n equal to 4, and we want to start from this this point here and end at this point, and we can only go down or right from a cell. Okay, and also one more condition is that we have, like, we can only go through once, we cannot step on a 0, right? So the number of valid paths from 1 1 to nn, let's say in this case the number of valid paths from 1 1 to nn is what? If we go down, then okay, then, like, basically one path is this, one path is here, like this, okay, and another path is, let's say if we go down and we go down from here, so second path is this. So actually you can see that it only has 2 paths, like this grid only has 2 paths which lead from 1 to n, I mean 1 1 to nn, and only go through once, right? And down right paths. So for this grid there is, like, the number of paths is 2, and we have to find out a grid, like construct a grid with number of paths equal to 3. Okay, so we have been given n, okay, and we have to construct a grid with the number of different paths to be 3 in that grid, right? So, and also if there doesn't exist anything, then answer is -1. Okay, so let's look at samples. Like in the samples they have given 2 and 3. For n2, the answer is -1. They are saying that the answer is -1. And why is that? Because on n2, like we have, let's say, 4 elements, this and this and this. We want to reach from here to here. So there are only two distinct paths, either this path or this path, right? So how can we have three different paths? So not possible, right? So -1 for 2. Okay, and for n equals to 3, they have given an answer. So for n equals to 3, they have given this answer. Let's analyze this. What they have written is 1 0 0, 1 1 1, and 1 1 1. Right. So let's count that how are there three paths in this grid. So one path is if you go like this. Okay. Then another path is, let's say, if you go right and then down and right here, right from here, right? And the third path was that if you just go all right and go down. Okay. So like basically what we have here is three paths, and we can simply observe that in the first path we are going from the column 2, this is column 2, this is column 3. So on the first path we are going from column 2 to column 3 in the last row. Then in the second path we are going from column 2 to column 3 from the second row. And in the third path we are going from column 2 to column 3 in the first row. And like to reach column 2 there's only one way, like this, like from here there's only one way to reach column 2, and once we are at column 3 we have only one way to go down, right? But to go from column 2 to column 3 there are three ways, and therefore there are total three paths, right? So this is for 3 by 3. But actually we can extend this idea for n by n also. Like this sample is very good. Like they have given this sample which is very convenient to us, because we can extend this example to n by n as well. Like we just need to ensure that the number of ways to reach this column is only a 1, and from here to here we have three ways. So like we will keep three ones here, like 1 1 1 1 1 1, and rest we will keep zeros. Like let's say here we'll keep some zeros so that we cannot move from here, like that will give us extra paths, right? So what we can simply do is, we can, let's say for n equals to 5 if I want to make, then I want to start from here and I want to ensure that the person goes in this path and reaches here. Okay, and then he will have three options, either to go from here or to go from like this or to go like this, and he cannot move further. So I will put a 0 here, and also I will put zeros everywhere else, like here also I'll put zeros here, so that the person cannot go down, right? The person has to go right, and here also I'll put zeros so that he cannot go down from here. Okay, so I'll just put all of these zeros, and here I have to put 1 because we have to reach here, right? So this is how you can make for 5 by 5, right? So like you can simply go to the second last column, and after reaching here you have three places, either you can go from here or you can go from here or you can go from here, and wherever you have reached you have to go down only. So you have total three paths, right? So this is how you can make it. That's the construction, that for n by n your entire first row would be 1, right? This entire first row is 1, and entire last column is 1, and these two cells are 1, right? That is 1 comma n minus 1, I mean 2 comma n minus 1, and if we have 1 indexing then 2 comma n minus 1 and 3 comma n minus 1. Okay, so that's how we can solve this problem. Alright, so I will show the code for this. Yeah, so we have int n cnn. If n is 2 or less than 2, then -1. Then I have this ans 2D grid, and I will set the entire last column and the first row to be 1. Okay, and also I'll set ans of 1, n minus 2 to be 1 and ans of 2, n minus 2 to be 1. Like in 0 indexing, it is that those cells, and then I'll print the ans. Right? So it is not very difficult. So let's move on to the next one. Now we have new operation. You are given an array A of n integers. You perform the following operation on it n minus 1 times. Choose an index I and let x is equal to ai plus 2 into ai plus 1. Delete ai and ai plus 1 from the array A and insert x back to the array A in the same place. More formally, you replace array A with one say I plus I minus 1, then x, and I plus 2 say n. At the end of n minus 1 operations, only one element remains. What is the minimum and maximum possible values of that last element? So they are saying that we have an array. Okay, we have an array from a1, a2, a3 up to an, and we have to like we can do an operation on any adjacent elements I and I plus 1, I and I plus 1, and we can replace ai and ai plus 1 with x. Like delete these two elements and insert x at that position, where x is equal to ai plus 2 into ai plus 1. Okay, so that's the value of x, and we can replace this. We can replace this ai and ai plus 1 with this x. Okay, and we have to find out that what is the maximum possible value. Like if we do this operation one time, then the length of the array decreases by 1, right? Because we are deleting two elements and we are inserting only one element. So we want to find out that, like after we perform n minus 1 operations, like if we want to perform the operation n minus 1 times, then what is the final last element's value? Like if we do this n minus 1 times, right? So the length will decrease n minus 1 times by 1. So finally only one element would remain. So what is the maximum possible value of this element? Maximum value and the minimum value. Right? We have to find it out, that what is the maximum possible value of this element and the minimum value of this element. If we can perform the operation on any two adjacent elements, and we have to do it n minus 1 times, right? So let's say, for example, if we have 5 to 7, okay, so for 5 to 7, if I do the operation first on these two, it would become like we can replace this 5 and 2 with 5 plus 2 into 2, so 9. So it would become 9, 7, and if we do it on these two, then it would become 9 plus 14, which is 23, right? So you can get 23 like this. And instead, if we do like from starting only, from in the starting we do 5 to 7 and replace this 2 7 with like 2 plus 2 into 7. So what does it become? It becomes like 5 comma 2 plus 14, which is 16, right? And then if we do it here, this 5 comma 16, so 5 plus 16 into 2, so 32, so we get 37, right? So we get 23 like this and 37 like this, and actually we cannot get better answer. Like we cannot get smaller than 23 and more than 37. Like this is the maximum possible answer. So the minimum is 23 and maximum is 37. Like I will tell you why it is not possible, but this is how you can get 23 and 37 using the operations. Okay, so how do we solve this? Now first thing I thought that if there was not a 2 here, like if this 2 was not there, then the answer would be pretty obvious, because we are removing ai and ai plus 1 and inserting ai plus 1. So essentially we are merging two elements like this into one. So the sum would remain same, like the sum of the entire array will remain same after the operation. So the last element that remains would be the sum only, right? So the answer would be pretty simple, like the minimum value are also sum and maximum also sum. Like we can only make the sum, right? But right now there is a 2 here, which is causing problems, right? So we cannot really do that. And like thinking about a sum does not also help. Like I thought about the sum for a while, how it changes, but that did not take me anywhere. Okay, so what we can think about is how to like greedily minimize the value or maximize the value. So let's first think about how to minimize the value. Okay, like what can be the minimum possible value of the final variable. Okay, so like if you have an array a1, a2, a3 up to an. Okay, so finally you are converting it into only a single element, right? A1, like it might be different from this a1, let's say b1. Okay, so if you are converting this into a single element, then of course all these elements must be performed an operation. Like you must have performed an operation on these elements, right? Like because you want to delete them, right? Like let's say if you have 1 2 3, so if you want to reduce the size of this, if you want to like make it one element, then you will have to perform the operations on these elements and delete them, right? And I also claim that at least once these elements would be the right side of the operation. Like we have, like in the operation that we have, we can choose I and I plus 1, right? We can choose two elements I and I plus 1. Okay, so this I is the left hand side and I plus 1 is the right hand side of the operation. So the element on the left hand side is as it is, like a3 plus 2a4, right? If I is equal to 3, then I replace this with a3 plus 2a4. So the left hand side remains as it is, but the right hand side gets doubled, right? So its contribution to the final element has doubled now, right? So like my claim is that all of these elements which are not the first element, they will come at least once as the right hand side. Like every element which is not the first element, like these two elements, they will come at least once as a right hand side, because if they don't, then how will the array length decrease, right? You can think about this. My claim is that all elements except the first one will come at least once as the RHS of an operation, right? Because if they don't come as the RHS, let's say if we have a 5 element array a1, a2, a3, a4, a5, and let's say that this a3 never comes as the RHS, then it is always the left hand side. So like either it is this one, or we have combined these two and it is this one. But then how will the array length become less than 3? It can't, right? Because if it is never coming as the RHS, then okay, we might do this operation as well, so it becomes size 2, but we'll have to eventually perform the operation on this a3 as well as the RHS, right? like the best we can do is make this size 2, like by doing this a1 plus 2a2, and like let's say combining these two and then these two, so it becomes a3 plus 2 into this element, which is a4 plus 2a5. So this 2 length array we can get by not doing anything to the a3, but eventually if I want to make this only one length, then I'll have to perform the operation on this right hand side, and so a3 will definitely come as an RHS in at least one operation. Okay, that's my claim. So you can see this, like you can think of it like this, and actually this thing that I wrote here is very helpful to understand that what's happening. Okay, like right now the array is a1 plus 2a2 comma a3 plus 2 into a4 plus 4 into a5, right? So like we had 5 elements, a1 a2 a3 a4 a5, and here also we have like 5 variables, and there are some coefficients with each variable, like with a1 we have 1, with a2 we have 2, with a3 we have 1, with a4 we have 2, and with a5 we have 4, right? So actually there are some powers of 2. Okay, like with a5 we have a 4, and why is that? It's because a5 has appeared twice as the RHS. Like once we performed the operation here, so it became like an RHS on this operation also, and like see what we did was we converted this into a1 a2 a3 and a4 plus 2a5. So this a5 came as the RHS in this operation, and then if we do combine these two, right, so again this a5 came as the RHS in this operation as well. So a5 came in the RHS 2 times, so that's why it got doubled twice. So 2 to the power 2, which is 4, right? So basically the contribution of each element would just be that how many times it came in the RHS. Okay, I mean like 2 to the power of that. So you can see that if we do this operation a1 comma a2, so this a2 came in the RHS a single time, so we have 2a2. Okay, so that is the thing, that the final contribution of an element would be 2 to the power k into ai, where k is the number of times ai appeared in the RHS of an operation, right? So we have to like minimize this and maximize this also. Okay, so first let's try to minimize this. Like we have an array, let's say 5 length array, a1 a2 a3 a4 a5, and we have to like merge these elements in such a way that the final sum of the contributions is minimum, right? Like we can do, let's say like what I claimed was that every element that is not the first element, that is from second to fifth, they will come at least once in the RHS, right? That is pretty obvious. So each of these elements will come at least once in the RHS, so their contribution would be at least like 2, right? 2 into a1, 2 into a2, 2 into a3, 2a4, 2a5. So my point is that these elements would come at least once in the RHS of an operation, and so their contribution would be at least twice, 2 to the power 1. Okay, and this a1 can never come in the RHS actually, like this a1 is the first element, right? So it cannot be the RHS in any operation, So its contribution will always 2 to the power 0, that is 1. Okay. So this is actually the minimum possible value that we could get. Like theoretically, we cannot get a value less than this, because every element will come in the RHS at least once. Like every element except for the first one will come in the RHS at least once, right? So this is the like theoretical minimum that we can get. We cannot get less than this. Let's say this is x value, then we cannot get less than x, right? So if we find out a way to get this value, then we would have the minimum, like x will be the minimum, right? Because we proved that we cannot get a value less than x, and we showed that how we can get x, so that's why x will be the minimum. So how do we get this value as the final answer? Like we want a1 plus 2a2 plus 2a3 plus up to 2an, right? So how do we ensure this? Like we basically want to ensure that every element from a2 to an comes in the RHS only one time, not more than that, right? So we can actually do it very simply. Let's say we have the array a1 a2 up to an. So first, like we'll merge from left to right. Okay, left to right. So let's say if we merge a1 and a2, it would become a1 plus 2a2 comma a3 comma a4 and so on to an. Then if we merge these two, like now this is one element and this is one element, so if we merge these two, then we will get a1 plus 2a2 plus 2a3, the first element, then a4 second element, and so on till an. So you can see that we are getting only once, like we are taking every element in the RHS only a single time, right? But actually in the LHS we are doing multiple times. Like you can see that this a2 was involved in the LHS when we did this a2 was in the LHS, and then when we will do this thing again, a2 is in the LHS, and like it will keep coming in the LHS. But if the element is in the left hand side, it doesn't matter, because left hand side is only one time, but RHS is twice, so RHS would come like this a4 के साथ 2 आ जाएगा, right? When we do a1 plus 2a2 plus 2a3 plus 2a4 comma a5 comma a6 and so on. So in this way we are ensuring that every element except for the first one comes only once in the RHS, and that's how we can get this value 2 to the like 1 into a1 plus 2 into a2 plus 2 into a3 plus 2 into a4 up to 2 into a5 or up to 2 into an. So this is the minimum value. Okay, so the minimum value is this a1 plus 2a2 up to 2an. Okay, but how do we maximize this now? Like we want to maximize this is the minimum value. How do we find the maximum value? So again we start with the array a1 a2 a3 up to an, right? So basically the final answer is what? Final answer is 2 to the power k1 into a1 plus 2 to the power k2 into a2 up to 2 to the power kn into an, where k1 is what? K1 is the number of times a1 came in the RHS. So basically k1 would be 0 only, because a1 cannot come in the RHS, so it is the first element. Then what is k2? K2 is the number of times in which element 2 came in the RHS. K3 is the number of times element 3 came in the RHS, right? And finally kn is the number of times an came in the RHS of the operation, right? So how many times can an element come in the RHS? That's what I ask you. Let's say if we have a4 also, a1 a2 a3 a4 up to an. So if I ask you that how many times at maximum can this A4 come in the RHS? So what will you answer? So at maximum, how many times can A4 come in the RHS? So actually, if A4 is in the RHS, right, then like let's say if I do this, then A4 is in the RHS once, but then these two combine to become one element, right? So initially there were 4 elements, but now there are only 3 elements after we combine them. So let's say if we combine them, it becomes A3 plus 2A4, right? Then let's say again we do the operation on this one. So again A4 comes on the RHS, so it becomes A2 plus 2A3 plus 4A4. A2 plus 2A3 plus 4A4. And let's say we do the operation on this thing also. So again A4 comes in the RHS, so it would become 8A4, right? A1 plus 2A2 plus 4A3 plus 8A4. Okay, and this is how it goes. But now the element is the first element, like now there are no more elements to the left of it, right? A4 is a part of the first element only, and so we cannot get A4 any more times in the RHS. So at max we can only get A4 3 times in the RHS, because every time we do the operation in the RHS, the number of elements decreases by 1, right? Like there were 4 elements, then if we combine these two, so now there are only 3 elements, and then if we combine these two as well, only 2 elements are there now, and then we can combine these two, only 1 element is there. So basically this A4 can only combine 3 times with the previous elements, right? Because there are only 3 previous elements. So in general, if I have one indexing, then the AI can only appear in the RHS I minus 1 times, right? Like basically A4 could come in the RHS only 3 times, right? Like this. Okay, but so like okay, now we have the range of Km basically. Like we know that this K2 will at max be 1, K2 is less than equal to 1, then we know that K3 is also at max equal to 2, and basically Ki is less than equal to I minus 1, right, from K2 to Ki. So actually for K1 also we can say that for K1 it is less than equal to 0, right? So in general Ki is less than equal to I minus 1. So basically we cannot get a value of more than, like if I just keep the maximum value of this Ki's, like basically I want to maximize this value, right? Let's say this is X, so I want to maximize this value, so let's keep the maximum value of Ki's, because this elements are positive, right? All the elements A1 up to AN, they are non-negative. So if we want to maximize this X, we will of course keep the maximum value for the K1s, for the Ki's. So what is the maximum value we get? We get 2 to the power 0 into A1 plus 2 to the power 1 into A2 plus 2 to the power 2 into A3 up to 2 to the power n minus 1 into A of n minus 1, right? So this is what we get as the maximum value. Like we know that the value cannot be more than this, like the final value can't be more than this, right? But actually it can be like, so we have to prove that we can reach this value. Like if we show a way to achieve this value, then we can say that it is the maximum, right? Similar to the minimum case. In the minimum case we showed that we cannot get less than this, right? And then we showed that how to get this. So this is the minimum. So in the maximum answer we showed that we cannot get more than this, so we will show that how to reach this value, and that's why it is the maximum. So if we have like a1, a2 up to an, and I want to ensure that every element comes in the RHS maximum number of times, then actually I can do it from right to left. Okay, like let's say if we have 5 elements only, a1, a2, a3, a4 and a5, then we can do it from right to left. Like this a4, a5, we can merge them to be a4 plus 2a5, right? a3, a2 and a1. So this a5 came once in the RHS. Then if we merge these two, so it will become a1, a2, a3 plus 2a4 plus 4a5, right? Sorry. Sorry. And so basically now we can combine these two. It would become a2 plus 2a3 plus 4a4 plus 8a5, and then we can combine these two. It will become a1 plus 2a2 plus 4a3 plus 8a4 plus 16a5, and that's how we can get that value, which is the maximum possible value that we can get. So we can achieve this value, and that's why this is the maximum answer. Like this is the answer. Okay, so basically the final answer is just like the final answer x. The minimum value is just a1 plus 2a2 up plus 2a3 up to 2an. Okay, and the maximum value is just a1 plus 2a2 plus 4a3 up to 2 to the power n minus 1 into an. Okay, so this is what you will get. So you just have to take the input of the array and print these two numbers, and the n is given to be very small. N is given to be 20, so we don't need to care about the overflow, because 2 to the power n is a very big number, right? If n becomes large, then 2 to the power n cannot be stored in integers, but here n is only till 20, so it will fit in an integer. Okay, so yeah, this is the code for that. In 10 CNN, take the input of the array, and I have these two sums like minimum and maximum, and minimum plus equals to a0, and from 1 to n I will add 2 into ai for the minimum, right? And then for maximum again I add a0, and then from I equal to 1 to n I add ai into 2 to the power I, because 2 to the power I, because it is 0 indexed, right, in this case. So ai into 2 to the power I, and then I print both the values. Okay, so this is what the problem wants us to do. Okay, so let's move on to the next one. Ones and zeros 2. Given a binary string fs, fs is defined as follows. Like fs is the same that they defined in the problem A, which is the number of prefixes where where count of 1 is at least as much as count of 0, right? So that is the meaning of fs. So you are given a binary string s of length n. Your task is to maximize fs by performing adjacent swaps. What is the maximum possible fs using n number of adjacent swaps, and what is the minimum number of swaps needed to obtain this maximum? So they are saying that we have been given this binary string s, okay, and we want to like maximize fx, maximize f of s, okay, and basically f of s is defined as the number of prefixes with count of 1 it should be greater than or equal to count of 0, right? And we want to maximize fs in the minimum number of moves. Minimum number of moves. Where one move is, we can swap any two elements adjacent. Like we can swap I and I plus 1. Si and si plus 1 we can swap. That is one move. So we have to find out the maximum value of fs. Okay. So like, alright, we have to do this. So guys, do you know about the concept called balanced bracket sequence or regular bracket sequence? Like we call a bracket sequence balanced if the number of opening parentheses of any prefix is greater than or equal to number of closing ones, right? Like we call it regular if it is valid. Like this is not valid, right? This is not valid because in this prefix the number of opening is less than the number of closing, right? So it's kind of similar to that. Like this problem statement is kind of similar to this balanced bracket sequences, but we want to maximize the number of prefixes where this happens, right? So in the balanced bracket sequence we make a graph, right? We can make a graph of the balance, okay, where balance is defined as balance is equal to number of opening brackets minus number of closing brackets, right? So we can plot this along with the n. Like as we move from left to right, we can plot this balance variable. Like for example, if we have this thing, opening, closing, right? So initially balance is 0. Then if we have one opening, so balance becomes plus 1. Then one more opening, it becomes plus 2. Then one closing, it reduces by 1. Then one opening, it becomes 2. Then one closing, it becomes 1. And one more closing, it becomes 0, right? So for a balanced bracket sequence, this sequence, like for a balanced bracket sequence, these values will be all positive or non-negative, right? Because that is what the definition is, that for every prefix the number of opening should be greater than or equal to number of closing. So if we take the difference of that, it has to be positive, right? So we will get an array like this, which is all non-negative for a balanced sequence. But for an unbalanced, like let's say this one, so initially it is 0, then it increases by 1, then it decreases 0, then it goes minus 1, and then it is 0. So this minus 1 is what's the problem. That's why it is not a balanced sequence, right? So anyways, why did I tell you this? It's because we can actually make a graph of this. Like we can make a graph out of this. Like we have initially 0, then we have 1, then we have 2, then we have 1, then we have 2 again, then we have 1, and then we have 0. This is the graph for this string, and for this string the graph would look something like initially we have 0, then 1, then 0, then minus 1, and then 0, right? So this is negative. We have negative area here, and that's why it is not valid. So like we can actually, this is just very common idea, okay? For bracket sequences, this is a very common idea that we can make graph out of the string, right? So similarly we can do the same thing for the 1 and 0 as well, okay? Like if we have a binary string, let's say 1 0 1 1 0 0 0 1, okay? So let's make a graph of this one as well. So let's say we have a 1, then a 0, then a 1, and then one more 1, then a 0, then a 0, then also a 0, and then a 1, right? So from this graph we can figure out that how many points, like how many, basically we can find out the value of fs. For this string, the value of fs we can find. Why? Because this prefix is positive, this is also, I mean, non-negative, right? We just want that the count of 1 minus count of 0 should be greater than or equal to 0, right? So here it is 1, here it is 0, here it is 1, 2, 1, 0, minus 1 and 0. So basically all the points that I marked in red except for this one, they are like those prefixes, they are all good, right? Like this point corresponds to this 1 length prefix, then this point corresponds to this 2 length prefix, third point corresponds to this 3 length prefix, and so on. So all these prefixes, like all of these points which are at the greater than equal to 0, they are all a part of my fs. So 1 2 3 4 5 6 7, so fs is 7 for this string, right? So basically we can make a graph, and from that graph we can figure out the value of fs. Like that would, the fs would just be the number of points on the graph which are at the like y greater than equal to 0, which are at a height of greater than equal to 0, right? So what we can do is we can basically swap any two adjacent elements. We can swap any two adjacent elements, and we will, like, we have to maximize the number of fs. We have to like maximize this value of fs if we can swap any two adjacent elements, right? So now let's think about how does this graph change if I swap any two elements. Okay, like let's say if I swap a 0 and a 1. Of course, if I swap two zeros or two ones, the string won't change, so nothing will happen. But if I swap a 0 and a 1, then let's see what happens. Okay, like let's say we have this 0 1 right here. Okay, so if I swap this 1 and a 0, what will happen? Like, or let's say in general, if I have a string, okay, let's say s0 or s1 s2 s3 up to, let's say we have s1 s2 s3, then we have a 0, then we have 1, and then we have, this is s4 s5 s6 s7. Okay, so I don't know what these values are, s1 s2 s3 s6 s7, but I know that we have a 0 1 here. Okay, so if I swap it and make it 1 0, then what happens to the balance of string, like s1 s2 s3 and s6 s7. So if I like do this swap of 0 1 to 1 0, so what will change for the balance? Okay, like how does this graph change? We want to find it out. So if you compare the strings, like for the length 1 prefix, the balance remains same, right? Because the elements in the prefix are same, s1 and s2. Similarly for length 2 prefix also, the elements are same, so the balance remains same. The value of c1 minus c0, it remains same. Then for length 3 also it remains same. Then for length 4, this length 4, the value of the balance actually increases. Like initially, basically there was a 0 here, but now there's a 1 here, right? For this prefix, for this 4 length prefix, there was initially a 0, but now there's a 1, and other elements are same, right? So if we look at the c0 and c1 for this, and c0 and c1 for this, so there was a 0 here and it got changed to a 1. So basically the c0 got subtracted by minus 1, like c0 got decremented and c1 got incremented, so by plus 1. So like if I look at the balance, which is c1 minus c0, it will get incremented by 2 plus 2, right? Because c1 got plus 1 and c0 got minus 1, and it was minus c0, so plus 2 happens to the balance, right? So basically for the prefix of length 4, our balance gets plus 2, right? So the balance of 4 plus equals to 2. That is what happens. If we swap a 0 1 to a 1 0, then this balance of this prefix gets increased by 2, right? But then if we look at the other prefixes after that also, like let's say if we look at the length 5 prefix, then the elements are same. This S1 to S3 0 1, S1 to S3 1 0. So the elements are same, so the balance remains same. And for all the prefixes after this also, the balance remains same. Right? The balance remains same for all the prefixes except for this one. So like if we swap this 0 1 to a 1 0, then the balance of this prefix gets increased by 2. So plus 2 happens. Plus 2 happens to the balance. Right? So if we look at the graph, like okay, if there's a 0 1, the 0 1, like if in my string I have a 0 1, okay, then in the graph, like you can see that wherever I have a 0, it gets decreased, and wherever I have a 1, it increases, right? Like I have a 1, so it increased. 1, then 0, it decreases, 1 increases, 1 increases, 0 decreases, 0 decreases, 0 decreases, and 1 increases, right? So whenever I will have a 0 1 in my string, so at that point it basically decreases and then increases, right? 0 1. So if we change this to 1 0, it will actually convert this, like it will increase this and then decrease this. Like changing this 0 1 to a 1 0 changes this downward triangle into an upward triangle, right? So like if we have something balanced string, like if we have a binary string whose graph looks like this, right? Then if we apply the operation on this index right here, like this is like you can see that this shape is there, right? Decreases and increases. Like here we can see that this decreases and this increases, right? So if we do the like operation here, we have a 0 1 here, so if we make it 1 0, this graph will change to this. Okay, like if I draw the new graph, it becomes like this, right? So like initially we had this point, like this point was not a part of fs, right? But we did the operation and it became a part of this fs because it became 0. So greater than equal to 0 it became a part of that. So like this point was initially not good, but we did the operation and it became good, like this, right? So we can simply try to make all of these elements good, right? Like let's say if I make this good, so it would change this to like this, and if I swap this, then this point becomes also good, and if I swap this thing, this point also becomes good, right? So that's how all the points can become good. So like this entire thing that I told you, the entire point of that was that what happens to the graph. Like until now, whatever we discussed, the first thing that we discussed is how to make a graph of that. Like we can make a graph, we can make a graph out of the S, right? And then the second thing we noticed, if we swap 0 1 to a 1 0, then how the graph changes. How the graph changes is like this thing right here would become this thing, right? And so we can do operations to like make sure that all the points are above the graph, like above the x-axis, right? But not always it is possible. Like it's not always possible that all the points come above the x-axis. Why? Because let's say we have 1 1 0 0 0 0, right? Or let's say 1 0 1 0 0 0. Okay, so if I make the graph of this one, okay, not, let's say we have this thing. Okay, so if I draw the graph of this, I have 1, then I have 0, then I have one more 0, then I have one more 0, then I have a 1, and then I have a 0, right? This is the graph for the string. So here I see that this pattern is there, right? So I can do the operation on and make this like this, right? And then maybe on this one also I can do the operation because I have this pattern, so I can make it like this. Okay, but now what do? I don't have anything like that, so I cannot really do anything because, okay, I have this thing, but it is already positive. So changing this to this doesn't really do anything. Like the number of points is still the same, right? So basically I cannot really change these two elements. Like I cannot really bring these two elements to the top, right? So in this case the answer is 4. 1, 2, 3 and 4 only, right? So let's think about why this happened. Okay, like in the string, actually there are many zeros but not many ones. Like here we have 4 zeros in the string but only 2 ones, right? So no matter what we do, like we want to make the prefixes have more number of ones, right? Like let's say if we could have rearranged this entire string in any way we want, right? Like basically if we can swap any two elements, then we can make any string that we want. Like we can rearrange the string into whatever we want, right? And essentially we want the maximum value of fs. So if we can rearrange this string into whatever we want, then the maximum would come when all the ones are in the beginning and all the zeros are after that, right? Like my claim is that the maximum value of fs comes when s is reverse sorted. Okay, that's my claim. And why is that? Like basically it is pretty obvious, right? That if we want that for all the prefixes, like if we have s0, s1, s2, s3 up to sn, like let's say if we have 5 elements, s2, s3 and s4. So the first prefix has s0, then we have s0, s1, then s0, s1, s2, s0, s1, s2, s3, s0, s1, s2, s3, s4. So these 5 prefixes are there. So like I want that every prefix should have count of 1 greater than equal to count of 0. So I want to have the count of 1 to be maximum. Like I want to maximize the count of 1, right? Essentially. So like let's say if I keep a 1 here, like if I have a 1 and I keep it here, then this 1 will contribute to only this prefix and this prefix, right? Like when I am counting the C1 for these two prefixes, only then this 1 would count in that. But for these three prefixes, 1 is not coming there. So instead if I keep the 1 right here, okay, then this 1 would be counted in every prefix. This prefix, this prefix, this prefix, this prefix and this prefix. So it is always better. Like it is better to keep all ones in the beginning, right? So like optimally your string would look like 1 1 1 1 1 1 0 0 0 0 something like that, right? 1 1 1 1. Let's say if you have 4 ones and 3 zeros, your string would look like 1 1 1 1 0 0. Okay. So in this case, what is the answer? Like the number of prefixes. So what happens is we have the balance is +1 for this, then +2, +3, +4, and then it decreases. So we have +3, +2, and +1, right? So basically all the prefixes are having a positive valence, like greater than or equal to 0. So that's why the answer is 7. Like all the prefixes, that is n prefixes, they are all good, right? But if we had more zeros, right, then this prefix would be good. This is good, +2, +3, +4. Then we have +3, +2, +1, and +0, right? Like after that, it is -1 and -2. So only till this +0, it is good. Like so, only this first 8 prefixes, they are good, right? Since we have 4 ones, we can afford 4 more zeros, and that will still be good. But more than that, we cannot afford, right? So if we have like k ones, then we can afford at max k more zeros. So the length is 2k. Like we can go till 2k, right? So that is the answer. Like the number of prefixes with number of prefixes having a positive valence is 2k, right? And like if the number of zeros is less enough, like basically the answer is minimum of 2k comma n. The answer is minimum of 2 into c1 comma n, where c1 is the count of ones. Because if we don't have enough zeros, let's say like if we have 4 ones and 2 zeros, then the answer is just n, right? N is 6 and the value of c1 is 4. So even if there were 2 more zeros, then the answer would be 8. But right now there are only 2 zeros, so we have the answer as 6. So the answer is minimum of 2c1 comma n. Okay, and this is achievable when we get this reverse ordered order, right? Just a minute. Yeah, so basically the answer that what is the maximum value of fx, I mean maximum value of fs. So that is the minimum of 2c1 comma n. Okay, but so that is what we want to print. But there's one more thing that they are asking, that what is the minimum number of swaps needed to obtain this maximum, right? So for that I showed you the graph. Okay, like the graph idea I showed for that. Like there's one observation that we can make using the graph. Okay, and then we can solve the problem. All right, so it's like the point is that the answer, the maximum value is minimum of 2c1 comma n, right? And now we want to calculate the operations, that what is the least number of operations that we want to do, that we can do to achieve this maximum value. So like let's say if I make a graph of this, like if I make a graph, then it will look like this. Okay, so here we have that, let's say this one, like these ones, they are good, right? If my string is like this, then 1 2 3 4 5 6 7 8, like this fs value is 8 for this string right here. Okay, but actually this is not optimal, right? This string is not optimal. We can increase it using swaps. Like we can maybe change this to this one and change this to this one, right? And now we have all the 10 peaks, right? So actually we can say that, like I have one more claim that the good prefixes, like basically what I am saying is ऐसा नहीं होगा, this thing can never happen that in an optimal case this prefix is bad and this is good. Like I will never have a bad prefix. My claim is we will never have a bad prefix before a good prefix. In the optimal case, like if we have achieved the maximum possible number of good prefixes, then it can't ever happen that we have a bad prefix. Like let's say here we have this one, and this one, and this one. They are the good prefixes, and this is a bad prefix. But it's not optimal, right? Like we can simply do the operation like this and change it to like this. So this also becomes a good prefix. So what I am saying is in the optimal string, that is in a string which has the maximum number of good prefixes, we'll never have a bad prefix before a good prefix. Like what that means is we will never have a negative valence and then later on we get something positive. Like sorry, my claim is that in my graph, if I have an optimal case, like if I have achieved the maximum possible value, like what is the maximum? Maximum is minimum of n comma c 2 into c1, right? So if I have achieved the maximum, then it can never happen that I have a bad prefix before a good prefix. That is, in my graph, I can never have a negative value and then have a positive value. Like if I have a negative value like this, if I have these three negative values and then I have a positive value as well, then this is never optimal, because I can always do the operation that is like this, and then perhaps we can, so now we have these two, right? And then we can convert this into the above and this also into the above, right? And so these points also become good. Okay, that's my point, that we will never have a bad prefix before a good prefix, right? So like in our string, in the optimal case, we will always have good prefixes, good prefix, and then we might have some bad prefixes at the end, right? Let's, like in the case of 1 1 1 1 0 0, like okay, 1 1 1 and 5 zeros. So we have good prefix, like we have 6 good prefixes and then we have 2 bad prefixes. So that is possible, right? So basically if we know the number of good prefixes, then we know that the first G, like let's say we know that the answer is mean of n comma 2 c1, right? The answer is mean of n comma 2 c1. So let's say it is G. Okay, so if it is G, then we can, like we know that the first G prefixes must be good. Okay, because I showed you that we cannot ever have a bad prefix before a good prefix, right? So the first prefixes must be good and the rest of them might be bad, right? So how do we like find out, like the problem is still the same, how to find out the minimum number of operations to make the first G prefixes good, right? So basically what we want is that the S1 should be good, S of 1 2 should be good, S1 S2, then S1, S2, S3 should be good, and so on up till S1, S2, S3 up till SG, right? So all of these should be good. That is, all of these strings must contain C1 greater than equal to C0, right? So like if S1 is there, it has only one element, so like it has to be 1. S1 has to be 1. Then S1, S2 has 2 elements, so like the count of ones has to be at least 1, right? But since we know that S1 has to be 1, so S1 is already 1, right? So if S1 is good, then this is also good, right? So we don't need any extra condition here. Okay, like I'm just counting that I'm just seeing that what is the condition. Like let's say if my G is equal to 4, okay, so we want S0 to be good, S0 S1 to be good, S0 S1 S2 to be good, then S0 S1 S2 S3 also to be good, and S0 S1 S2 S3 and S4 to be good, right? So what that means is that in this string I want the count of 1 to be at least 1, in this string also I want the count of 1 to be at least 1, then in this string I want the count of 1 to be at least 2, in this string I also want the count of 1 to be at least 2, and in this string I want the count of 1 to be at least 3, right? So how do we like calculate the condition for that? So actually the condition is like if we have the string, okay, and I want that this like if I want that this condition holds, okay, like C1, that is in this string the count of 1 should be at least 1, in this string the count of 1 should be at least 1, then in this string should be at least 2, and so on. So like what I can say is that in my entire string, so in this case G is equal to 4, right? In this case G is equal to 4, so we have only checked till S0 to S4. Sorry, G equal to 4 के लिए we will check only till S3, like length equal to 4, right? Yeah, so here we have G equal to 4, so we checked only till 4 prefixes. So this is the condition that for all of these prefixes to be good, then the count of ones in this first string should be at least 1, count of ones in the second prefix should be at least 1, then count of ones in the third prefix should be at least 2, and the count of ones in the fourth string should be at least 2, right? So you know that these strings are a part of a larger string, right? Like let's say we have a 6 length string which has two ones, okay, like let's say we have 0 1 0 1 0 0 1 and 0, right? So in this case the answer is 4, right? Min of n comma 2 into number of ones, so which is 4, right? So I want to like swap these ones, like in one move what I can do, I can swap 0 and 1, right? That is, I can bring this 1 to the left by one place, correct? So I want to ensure that all these conditions should be fulfilled, okay? So what can I say? That if in S0 this count of 1 should be at least 1, that means I need to have the first 0 at this S0 position, right? Then in S0 S1, if I want the count of 1 to be at least 1, like okay, if I have S0 to be 1, if I already have S0 1, then of course this S0 S1 will definitely have C1 greater than equal to 1, right? Then if I have S0 S1 S2 to be 1, like if I want in this string that my count of 1 should be at least 2, then basically the second one in the string has to be in these 3 indices, right? That's the condition. Like if I want that if I want that the number of ones in this string should be at least 1, then my first one should be in this range from 0 to 0. Okay, like see, in general, if I tell you that from S0, S1, S2 up to Si, if I want that my count of ones should be greater than equal to some k, okay, then that means that my kth one should be in the range of 0 to I. Like my kth one in the string should be in the range of 0 to I. Like here we can say, like here we have that the first one is at the index number 1, like index 0, 1, 2, 3, 4, 5, right? So the first one is at index 1, but for this condition to be true, the first one should be in the range 0, 0, 0, right? Then for this one to be true, the second one should be in the range 0, 2, right? And so on. So like the point is that the first one should be in the range 0, 0, but it is at the index 1. So to bring it to this 0, 0 range, we have to make one swap, right? Then the second one, which is at index 4, should be in the range 0, 2 for these two prefixes to be good, right? But it is at index number 4, so we have to bring it to index number 2 by swapping. So we will have to swap 2 times, and therefore to make this like to bring this one to the required positions, we will have 1, 0, 1, 0, 0, 0. Like this string will become this string, and it will take 3 operations. One operation for this first one and 2 operations for this second one. So the answer is 3. Like kind of this is the solution, but I think I'll explain it one more time to be more easy to explain. Like I will try to explain it in a better way. Okay, again, let's see it again. Like what I proved to you was that we will never have a bad prefix before a good one, right? Because if we do, then that would mean that like somewhere I am negative and I have reached positive, so definitely there would be a pattern like this. So I can convert it like this and it will become positive eventually, right? So we will never have a bad prefix before a good one. That is all. Like in our maximum case, if the answer is k, then the first k prefixes would be good, right? So for the first k prefix to be good, what is the condition? Like let's say if I have k is equal to 4, right? So I want that in my string S1, S2, S1, S2, S3, S4, S5, or let's take 0 indexing, like S0, S1, S2, S3, S4, S5 and S6. Let's say we have 7 length string and the answer is 4. So like we have 2 ones in the string, right? We have 2 ones and 5 zeros. Okay. So in my final string that I rearranged and got, I want that the first 4 prefixes have to be good, right? So basically this prefix must have at least a 1. This prefix also must have at least a 1. This prefix must have at least 2 ones, and this prefix must have at least 2 ones, right? So what do these conditions mean? I can say that the first one in the string has to be at this position, right? And the first 2 ones have to be in this range. That is, the second one has to be in this range. Like if the first one is in this range and the first two ones have to be in this range, that means the first two ones have to be in this range, right? Like for all of these four to be good, I want that the first one should be here, the first two ones should be in this range. So like if I can rephrase this as the first one should be at index 0, the second one should be at index 0 to 2. Then if I want, like if I had a third one also, if I had three ones, then I would want the third one to be in this range from 0 to 4. Okay, so that this prefix can be good as well. Like if I have three ones in this range, then this prefix until 4 would also be good, and prefix until 5 would also be good. Okay, so that is the thing, that if we want k to be answer, like k to be the answer, then I would want the ith one to be in the range 0, 2i. Right, if this is 0 indexed and this is also 0 indexed, so I would want my ith one to be in the range 0, 2i. So in my original string, if it is already in this range, then the cost is 0. To make it, like we won't need to do any swaps to take it here, right? So if already it is in range, then the cost is 0 for that one, and otherwise it is after that, right? Otherwise it is like after 2i, so I'll have to bring it to 2i. So the cost would be, like number of moves would be j minus 2i, where like if the one is at index j, then I will have to bring it to 2i using swaps. So the cost would be j minus 2i, right? So that is the answer. Like we have to just add up the cost for all the ones. Okay, and that would be the answer. So I hope this was understandable, and if it was not, then you can perhaps watch the video again. And if you are still not understanding that how it works, then you can DM me on Code Forces. Okay, and I'll answer you. Like my handle is Prady, Prady, and you can DM me here. Okay, and I'll answer your queries. So I'll show the code also. I mean, the code is pretty simple. So we have int scene and stringness series. Ans is equal to min of n comma 2 into count of 1, right? And I'll print the answer also. Then I want the operations, right? So for all the ones, I will count the operations to bring them to the range 0, 2i, right? For the ith one, I will try to bring it into the range 0, 2i. So I will first store all the positions of these ones. Like in my string, I will store the position of all the ones, right? So if for int I equal to 0, I less than minus I plus plus. If si is 1, then pause dot pushback I. Okay, and this is my counter, like final answer. So for int I equal to 0, I less than pause dot size I plus plus. So I want that my ith one should be in the range 0 to 2i. So if it is already in range 0 to 2i, then I'll continue. Like if pause of I is less than equal to 2i, then continue. Otherwise, if 2i is less than n, actually we don't need this condition, because if 2i is greater than n, then this will happen automatically. But yeah, like ith one I want in the range 0, 2i. So if it is not already less than equal to 0, 2i, then I'll add to my answer pos I minus 2 into I. Like this is the number of moves to bring that from pos I to the point 2i, right? Okay, else break, that means because if my 2i is not less than n, if it becomes greater than n, then for the future i's as well, like if I keep increasing the I, it would still be greater than n. So I don't need to loop anymore, so I just break. Actually, instead of this, I could have just simplified the code. Like I can just replace this with count plus equals to max of 0 comma pos of I minus 2 into I. Okay, so this also works. If I run it, then it would work. I just run this on CodeChef. Yeah, it should work. So I'll submit this. Yeah, it works. So this was the solution for D, and that's it for the today's PCD. And if you have any doubts about any problems, then you can DM me on CodeForces and I'll answer it. It might happen that you did not get D, so for that you can you watch the video, or you can read the text editorial as well. Like on CodeChef, if you didn't know, you get an editorial which is textual as well. Like if you can click this and it will take you to the textual solutions, and you can read this as well if you are comfortable with that. So this problem OZ, that is the thing. Okay, so you can read this, but anyways, that's it from my side, and I hope you got it. Thanks for watching. Bye.